Good morning. We are starting lesson 9.2 today, theoretical and experimental probability. I'll tell you ahead of time, these notes are pretty short. That's it. So we'll be able to move through these notes fairly quickly. Theoretical and experimental. There's a difference. Theoretical is what should happen. So theoretically, right, we kind of use that in our everyday vocabulary. Experimental is what actually occurs during the experiment. So if we're talking tossing a coin, well, the theoretical probability of getting heads, no matter how many times you do it, ideally is 1/2, right? So the probability of flipping heads is 1/2, theoretically. The probability of flipping tails is 1/2, because the other side, 1 out of 2 sides, is tails. So that's 0.5 or 50% if we do the decimal and the percent. So that's ideally, theoretically, what should happen. However, we all know if you actually do that 100 times, it doesn't mean that you're going to get heads exactly 50% of the time. So it doesn't mean you're going to get 50 heads and 50 tails, right? Because it might change, right? You might get a little more in this case. Let's see, in the experiment, we got heads 56 out of 100 times. So ideally, this experimental and theoretical probability will match. However, it won't, right? It won't always match. The experimental is what actually happens. The theoretical is what should happen. And then you're going to compare the two probabilities. So theoretical is less than the experimental, because in the theoretical probability, it was 50%. The probability of landing on heads was 50%. And the experimental probability was 56%. So I just use an inequality to compare those two. So theoretical is less than the experimental. Now, the more times you do an experiment, the closer you will get to the theoretical probability. So if you flip a coin 5 times, let's make it even. So if we flip a coin 10 times, we might get heads 7 out of those 10 times, right? It's just chance. So the experimental probability would be 70%. However, if we do it more and more, if we do it 20 times, we might get, 12 out of 20 times, which is closer to that 50%. The more times you complete the experiment, the closer that probability, closer the experimental probability will get to the theoretical probability. So again, theoretical probability is what should happen. Experimental probability is what actually happens. And this is what I just said. So the more times we complete our coin flip, the closer we'll get to our theoretical probability. Alrighty, let's talk about the theoretical and experimental probability of a number cube. Theoretically, so yesterday, or 2 days ago, 9.1, we worked with only theoretical probability. Really, yeah. The probability of getting a 6 on a number cube. Well, a cube has 6 sides. One of those sides has the number 6 on it. So the theoretical probability is 1/6, right? So let's look at the experimental probability, though. That is not what should happen, it's what actually happens. So if we roll a number cube 75 times, and it landed on 6, 20 of those 75 times, well, then the experimental probability, what actually happened, of getting a 6 was 20 out of 75. Now let's convert both of these numbers to a decimal and a percent. You will be likely asked to do that in your homework. So the number cube, 1/6, the decimal is it's 0.1666 repeating. So I'm going to put about 0.17. Or here, let's do 1/6, and we'll have the repeating over that. But for the percent, we'll do about 17%. Now, 20 over 75, whether it asks you to do a percent or a decimal or a fraction, they will want the fraction in simplest form. So let's divide by 5. We'll get 4 out of 15. And 4 out of 15 as a decimal is about 0.26 repeating. And our percent, let's do about 27%. Alrighty, so now we need to compare them. So theoretically, it's about 17% to get a 6 on a number cube. But our experimental probability was 27%. However, that's only because we did it 75 times. If we increase that to 150 times or to 250 times, our experimental probability, that 27%, will get closer to the 17% theoretical probability. All right, and let's compare theoretical to experimental. The theoretical was 17%, the experimental was 27%, so the theoretical was less than the experimental. That's all you need to do to compare. Alrighty, our last example. You have a spinner broken into 5 equal sections, all with different colors. One of the colors is red. You spin the spinner 80 times and land on red 12 times. Compare the theoretical and experimental probabilities and explain. So right here we're looking at a spinner, 5 equal sections. One is red. So we're talking about the probability of landing on red. Alrighty. So theoretically, and my spinner is not 5 equal sections, sorry about that. Theoretically, we should land on red 1 out of 5 times. So probability of red, be sure you always write that, is 1 out of 5. So we've got 0.2, 20%. Experimental probability, that's what actually happens in the experiment. So you spin the spinner 80 times, land on it 12 times. So probability of red ends up being 12 over 80. So 12 over 80 as a reduced fraction is 3/20. And as a decimal, it's 0.15, it's 15%. Alrighty, and let's compare theoretical to experimental. Theoretical was 20%, experimental was 15%. Alright, and in this case, which we haven't had just yet, the theoretical was greater than the experimental. So again, if we completed this experiment more than 80 times, if we increased it to 100 or 200, that experimental probability of 15% will get closer to the theoretical probability of 20%. Alrighty, let me know if you have any questions while working through your homework. We are not doing the got it's today just because it's pretty basic. Let me know if you have any questions and get that homework submitted on time. Have an awesome day.